All right, students, go ahead and review chapter 7 in this book, which is Inequalities and Stats. Okay, so the one thing you want to remember is if you multiply or divide by a negative, you must switch the inequality. And that is often forgotten, especially since in most books they do not focus. We don't have a lot of problems on inequalities, like a chapter on it, but other than that, you mostly just always dealing with equations. So when they finally come back and do an inequalities review or the SATs, people forget it. So what do I teach? I teach that you don't have to remember that. As I've already pointed out before, when I've shown you that whenever I solve for a variable, I look for the coefficient of that variable. If it's positive, it stays on that side. If it's negative, I move to the other side so it becomes positive. And in that doing so, then I'm not going to go ahead and divide or multiply by a negative to have to remember to switch that inequality. That's where this comes into play if you've been doing it my way. Otherwise, you're going to have to remember that rule. So example here, I'm solving for D. Well, D here is positive, so I'm going to leave it on that side, and that means I'm just adding the 16 across. So I have D over 6, oops, inequality symbol, less than 16 minus 9, which is 7. Okay, now last step, multiply both sides by 6. I'm left with D is less than 42. Notice I didn't have to remember switching any inequality signs because I made sure that it was positive. Now here's an example where it's not. The coefficient here of K is what? It's not -1, it's -1/5. You have to include the bottom as well. So since that's negative, I'm going to move that across to make it positive, and I'm going to add that across. Inequality sign doesn't switch. So I have K over 5, because it's positive now. 10 minus 3 is 7. Now I'm just multiplying both sides by 5. And I get K is less than or equal to 35. By the way, you always start rating, if you're going to talk about being smart and then helping yourself in graphing inequalities coming up, you start with the variable. It's much easier to understand that. And if you've forgotten with your inequalities from middle school, it always points toward the smaller number. So K is smaller than or equal to 35, or you can say K is less than or equal to 35 is the better way to say it. Okay, now if I have variables on both sides, we've talked about this before in solving variables. What side should I bring it to? Again, I want it to be positive, so I don't ever have to divide by negative. I bring the smaller over to the bigger sign, and then it becomes positive. Okay, so that means subtract the 4 across, and that means this constant of -20 is going over the other side. So I have 6n minus 4n is 2n, and that -20 becomes positive 20 minus 6 is 14. Last step, divide by 2, and I get n is less than 7. Again, notice I'm not ever divided by or multiplied by negative, so I'm not having to ever remember to switch the inequality sign. This is why I've taught you to do this all along with solving for x. 4 more than the quotient, you gotta remember quotient is the answer to a division problem, so it's gonna be a fraction now. 4 more than the quotient of a number, that's gonna be x and 3. So there's the quotient, x divided by 3. 4 more than that, so that means plus 4, is at least, that means greater than or equal to that number, which is x. Okay? So that's setting it up. I have to be able to interpret my words correctly. Now, this is 1/3 x, and that's 1x, which is smaller. This one is. So the smaller goes to the bigger side. Okay, so it remains positive. So it's 4 greater than or equal to 1x minus 1/3 x is 2/3 x. And now I multiply both sides by the reciprocal as we've done before. 3 halves. So those cancel out. Whatever I do to one side, I do to the other side. That 2 cancels the 4 2 times. 3 times 2 is 6. So x is less than or equal to 6. Again, no dividing by positive, by negative or multiplying by negative. dividing or multiplying by negative as I wrote. So I don't have to remember about switching that inequality sign. So that's the reason I teach you to solve for x as I have. All right, now we're going to go ahead and graph compound inequalities. Compound means two or more inequalities. So sometimes they are separated out like this, and sometimes they write them together. That's still two inequalities. This can be written as z is greater than or equal to -1 and z is less than or equal to 5, and then they'd be written out as 2. But this is written together as 1, okay? So when it's in between like this, the word is always and means it's going to be shaded in between the endpoints, not to the outside. Almost all the time in ors, they're shaded out to the sides, going to the outside when you see the word or. So that's going to be a major difference that you need to get down between and or. So here it says b is greater than 3. Remember, if it's greater than, it's not equal to, it's an open circle. Greater than is to the right. I put an arrow. Or b is less or equal to 0. Less or equal to means it's a solid circle because it equals 0. The open circle means it doesn't equal that number, so it doesn't equal 3. And there's that one. Here, I have closed circles on both at -1 and +5, and it's shaded in between them. Write a compound inequality for each solution set below. Okay. Um. So, uh, I would say b or x, doesn't matter, is greater than -3 and less than or equal to +3, right? Because that's an open circle if you can't tell, and this is a closed one. All right, I'll only make up one that goes in opposite directions. So this is going to be b is less than or equal to -1, or b is greater than 4. Okay, so when they're going to the outsides like that, the word's or. When it's shading between is and, or I can write it as a compound inequality. Okay, solving absolute values. Absolute value equations, which means it's got the equal sign, or inequalities have two equations slash inequalities, one or the other, of course, depending on what the symbol is, to solve. Number one, first one, just take off absolute value. Symbol and solve. That's the first answer. Second one, take off absolute value. Switch inequality sign. Obviously, you can't switch an equal sign, so this is just dealing with inequalities. Inequality sign. And multiply, or and multiply the non-variable side by -1, which means and take the opposite, which means negative, of the non-absolute value side. Oops, non-ABS. Non-absolute value side. Okay, so the first one is take it off. 3 minus y is greater than 2. Again, I see that it's negative, so that's why I chose 1. I'm gonna move it to the other side, make it positive, which means subtract this across. 3 minus 2 is 1. So y is less than 1. Remember, it points to the smaller one. If you see the greater than sign here, think that's or. Think instead of saying greater, say greater. Change the last 2 letters of ER to OR, and that will remind you to use the OR symbol. So y is less than 1, or, because if you write it wrong, you get it wrong. And then the second one is 3 minus y. I told you to switch the inequality sign and take the opposite of the non-absolute value side. So that would be the right side. Again, my y, the one I'm solving for, is negative, so I'm going to switch it to the other side. And I'm going to therefore add the 2 across. So that y is greater than 5. So y is less than 1, that's that way, or greater than 5 that way. Both open circles because neither has an equal sign with it. Okay, let's do one more. I chose the other one, so this is a less than. So instead of less than, just add a D to it for than, and that tells you to use the and in between. So the first one is just 2z minus 9 less than or equal to 1. This is a positive 2z, so I keep it there, add the 9 across. 2z is less than or equal to 10. Z is less than or equal to 5. So if z is less than or equal to 5, and, so you don't forget, now I have to solve it when, let's change this, 2z minus 9, remember I switch the inequality symbol and do the opposite of that side. It's still, the coefficient of z is positive, so I leave it on the left, add the 9 across, 9 minus 1 is 8, and last step divide by 2, so z is greater than or equal to 4. So we have and z is greater than or equal to 4, so it's greater than or equal to 4, closed circle, less than or equal to 5, shaded in between. Okay, so you're always going to have 2 equations if they were equations, or 2 inequalities to solve if you have an absolute value graph. For the bar, write an open sentence involving the absolute value. Can't tell, this is shaded. Okay. A lot of people take, so I know this says x is greater than or equal to 3. And this one says x is less than or equal to negative 3. So I need something so that it comes out to be that answer. Okay. I take the midpoint. Is 0. And so if I say absolute value that is less, since it's going out to the outside, it's got to be greater, and it's solid, so it's like this, and I put a 3 there. So that now means x is greater than or equal to 3, which we see that, or x, remember, switch the inequality sign and take the opposite, x is less than or equal to 3. Okay. So I took the midpoint. And so let's see if I drew out another one here. Let's see if this works. So 0, 1, 2, 3. Let's go that and open circle that way. So it's at 1 and 3. The midpoint is 2, so it'll be x minus 2. Okay, and how far, again, it's going to be greater than or equal to, how far is it going out from this midpoint to this point? I told us a 1. Okay, and so I'd put the 1 there. Let's see if this works. The first one is going to work. X greater than or equal to 3. The second equation, or second inequality, x minus 2 less than or equal to negative 1. And then I have add the 2 across, and 2 minus 1 is 1, so that does work. X is less than or equal to 1. Okay, so it's going to be X minus the midpoint. The midpoint was 2, absolute value. And then how far is it from that midpoint to each of the circles? A distance of 1. That's going to go on the side. So this goes out to the outside. It has to be an or, so it's a great tour. And it was, oh, I made them, sorry, I made them open circles, so it's just great tour. There is no equal sign with it. And so same thing over here. Got to take off the equal sign. They were not shaded in. Okay, next. Box and whisker. Compare box and whisker plots A and B to answer each question. So I'm going to just tell you the types of questions. First off, this is Q1, Q2, Q3, Q4. Okay. Q1, what that means is 25% of the information data is below it. It's 25% from each quartile. So from the beginning to this, that's 25%, 25% there, 25% there, 25% there, and 25% there. So they could ask you what percent of the numbers are above 70. Well, here's 70. That's 50% above. What percent are below? 50 also. What if they say what percent of the numbers are below 80? Well, that's 75. 25 plus 25 plus 20. What percent is above? 25. Okay. If they brought it down here, what percent are below 65? 25%. What percent are above 65? 75%. Okay. So that's how that works. They can say which one has a bigger interquartile range. Remember IQR, interquartile range, is Q3 minus Q1. Well, this Q3 minus Q1 is 80 minus 65, which is 15 for A. But look on B, it's 85 minus 60, which is 25 for plot B. So obviously, plot B would have, not P, but B, would have a bigger interquartile range. Okay, so those types of questions you get there. And that answers it. Or they could just ask you what numbers at quartile 1, what numbers at quartile 2, what numbers at quartile 3. Okay, and you just list the number that's actually there right there. Okay, 18 minutes.